Hi everyone. So today I'm going to explain you the various formulas related to the cases when beta is less than 90, when beta is equal to 90, when beta is greater than 90. So in the previous session we have discussed how to construct the or how to draw the velocity triangles at inlet and outlet. So as in the previous case, this is the case when beta is less than 90. So this is the diagram of inlet and this is the diagram for the outlet of the smooth curved veins. Similarly case 2. So this is the diagram for case 2 when beta is equal to 90 degrees. So here it is beta that is equal to 90 degree perpendicular to the this, and this is the velocity of the flow at the outlet. Then this is the case 3 where beta is greater than 90. So here it is the velocity triangle and this is the line and this is the beta is greater than 90. So in this session, so we will discuss the formulas, what is the force and work done for the this three cases. Okay, so let as in the previous, d is the diameter of the jet of the water that will be flowing, and a is the area of the cross section of the jet, and v1 and v2 are the absolute velocities of jet at inlet and outlet respectively. Let initial velocity u is equal to u1 for a inlet 1 and u2 for the outlet of the jet, that is velocity of the vane, u1 for inlet and u2 for outlet of the vanes. Alpha and beta are the angle made by absolute velocities with respect to horizontal at inlet and outlet respectively. Alpha is inlet for 1 at inlet and beta is the outlet of the velocity triangle for the vanes. Then Rw1 and Rw2 are the relative velocities of the jet at inlet and outlet respectively. Okay, so this is the initial velocity of inlet and initial velocity of outlet, and this is the relative velocity of inlet and relative velocity for outlet. Theta and phi is the angle made by relative velocities with the horizontal at inlet, that is theta, and at outlet that is phi vanes. Okay, next one, since the vane is moving, here it is moving, jet will strike the vane with a relative velocity vr1. Okay, as it is moving, then its impact result of water will be striking that vane, that is equal to r vr1. If the vane is smooth, then there is no shock. The jet leaves the vane with the same velocity as that of the inlet. So suppose this vane is smooth, so whatever v1 is there, that will be v2. If it is rough, then there will be change in v1 and v2, velocity 1 and velocity 2 respectively. Therefore rv1, relative velocity of 1, is equal to rv2 in case of a smooth curved veins. Then the vector diagram of the v1 and u1. Okay, now force exerted by the jet on the moving unsymmetrical curved vane when the jet strikes the vane tangentially at one of its end and is given by impulse moment equation. Okay, so case 1, first one, that is when beta is less than 90. Okay, then force is equal to, as in previous case, F is equal to rho into Q, okay, into V1 minus of V2. Okay, therefore F is equal to F force in equal to force in F direction, then Q is equal to discharge A into V, that is V A into VR1, relative velocity of R1. Then v1 is the horizontal component with respect to relative velocity r1, that is nothing but the cd. See here the diagram, here this is the relative velocity, that is nothing but vr1 with respect to horizontal cd. Okay, and this is the diagram, this line ad, and this is ac, and this is cd. Okay, therefore AD minus F is equal to AD minus AC is equal to, where AD is VW1 and minus of U1. Therefore, U1 equal to VW1 into U1. Okay. Then next, where V2 is the horizontal component of relative velocity R2, that is equal to GH is equal to FG plus FH. So in the diagram, so here it is GH is equal to, total GH is equal to FG plus FH, as it is in the diagram, velocity triangle at the outlet. Okay, GH is equal to FG plus FH. Therefore that velocity V2 is equal to minus of VW2 plus U2. Therefore force in x direction is equal to rho A into VR1 into VW1 minus U1 minus VW2 into U2, as in the diagram. Therefore rho A into R1 is equal to VW1 minus U1 plus VW2 plus U2. For the simplification, if we can, that will get a force in x direction equal to rho A into R1 into VW1 plus VW2, that is R relative velocity 1 into then plus R VW1 plus VW2. Okay. Next condition or case 2, when beta is equal to 90 degree. So beta is equal to 90 degree. This is the diagram when beta is equal to 90 degree. So see, this is diagram, this is G and E, and this is F, this is beta is 90 degree. Here V2 is equal to Vf2. Okay, then V relative velocity or Vr2 is here, and U2 is initial velocity for that. Okay, so we are dealing with that beta is equal to 90. So when beta is equal to 90, then VW2 is equal to 0. Then force in x direction is equal to rho A into VR1 into VW1 plus 0. Therefore f of x is equal to rho into A into VR1 into VW1. Okay. Last case, that is case 3, when beta is greater than 90. So VW2 is negative. So here we can see the figure here. So when beta is greater than 90, so this is U2, this is F, this is F, this is G, and this is F, and this is E. Here VR2 is here, and VF2 is here, and see this is the VW2, F and H and F is VW2, and this is the beta angle. Okay, therefore case 3, okay, this is the case 3, when beta is greater than 90, VW2 is negative. Therefore because it is beyond 90, right side f of x is equal to A into VR1 into VW1 minus VW2. In general, we know that f of x is equal to rho A into VR1 plus VW1 plus or minus VW2. Therefore, work done per second is equal to force into F, work done is equal to force into V, velocity, that is f of x in that direction into initial velocity u. Therefore, f of x is here. So, rho A into VR1 into VW1 plus or minus VW2. So therefore work done per second per unit weight is equal to rho A into VR1 into VW1 plus or minus VW2 into U. So as it is above formula, the unit weight is equal to mass, that is weight into gravity. Similarly, as it is rho A into VR1 into VW1 plus or minus VW2 into U divided by rho A into R1 mass is nothing but density into area. Okay, r1 into q into g. Then for work done per second is divided by unit weight is equal to, so for the simplification we'll get vw1 plus or minus vw2 into u divided by g. This row get cancelled, a get cancelled, v1 will be get cancelled. So this will be the final remaining thing. Okay, thank you. Next we'll go for the problems related to this. Okay.